A very important concept in calculus is of mean value theorem. We have spoken about derivatives. It is one of the application of it. It talks about the average slope. Now what it essentially tells us is, for example, okay, see, you can see the diagram out here. Now there is point A, there is point B. Say we are working in time. Okay, say just as an example, say we are working in time, and this is the distance that we are covering, and this is the distance function. This is some distance that we are covering. Okay, so say in 6 minutes you are covering 30 kilometers. Okay, say in 6 minutes you are covering 30 kilometers. The same thing can be said in a different manner, as that the speed of this person is 5 kilometers per second, 5 kilometers per second. So this average is essentially something that is told by mean value theorem. Mean value theorem says that there exists at least one point where the slope of the tangent is equal to the mean slope. Okay, to the mean slope. And what will be your mean slope? Mean slope will be this average written out here. Okay, this average here, sorry, this average. So FB minus FA upon B minus A will be your mean slope. Okay, mean slope. This is the mean slope. Okay, so that's what your mean value theorem actually tells you. So the theorem, graphical interpretation of this theorem essentially says that there exists at least one point where the slope of the tangent is equal to the mean slope. Now the mean slope will be this slope of this secant line. Okay, slope of this secant. The mean slope will be slope of this secant. So if you take it up, a parallel line will create a tangent here. That is point C. So there exists at least one such point. So that is point C, and there is such one point. Okay, so that's the graphical interpretation of mean value theorem. And mathematically, if you talk about it, it says that if fx is differentiable on any open interval and continuous on any closed interval AB, okay, then there exists a C between A and B such that FC equals to FB minus FA upon B minus A. Now, an important point that I want to mention out here is that there might be more than one such point. So there might be a function, say, like this, which looks like this. There might be one such function. Okay, then in that particular case, there will be not just one point but more than that. Okay, I can make two parallel lines to this secant touching this point and this point. So there are 2 points between two such points. So it just says that there will be at least one such point, but there can be more points which satisfy this condition.